test when? Tuesday next week. Okay? And I was going to put it on Monday, but I know you don't like Monday tests. And I thought that there might be some chaos with Friday, possibly. Like some people might have to go set stuff up or do things. Winterfest. So I thought this Friday might be a little bit discombobulated. So I thought we'll throw it on Tuesday. Okay. So I evaluate the following integral. I want you to look at this and think about substitution. We're going to do substitution. I want you to look at it for about 40 seconds and talk with your partner and try to figure out why this is significantly different than what we did yesterday. Ready, set, go. Okay, 5, 4, 3, 2, 1. Is there somebody who can summarize why this is a significantly more difficult problem than yesterday? Yes. Right. So in this situation, if it was x to the first, you would say no big deal, right? Because the derivative of the inside matches the degree of what you see there. However, in this situation, we have an x cubed. And so that's a problem. And so you would be left to simply multiply this out 5 times, which would make you very angry. Can we show you a better way? This would be what we would call slightly more challenging substitution. But I will say that these are not the problems that generally people get wrong on the test. People are making simple mistakes with radicals and things like that. So you guys generally do well with this. What do you think u is? And it is x squared plus 2. And so when I do du, I get 2x dx. And I don't have a 2, do I? So I'm going to write as 1/2 du is equal to x dx. Now, to try to help you out, and this is one of the kind of areas of growth you want to see as a mathematician, is being able to see an expression, be able to see it represented in multiple ways. And I'm going to rewrite this to be the integral of, I'm going to write x squared times x squared plus 2 raised to the 5th power dx. Now, for some of you, you're like, you didn't need to write it like that, Mr. Gantz. I already see that. Good for you. Must be great to be so smart. But you know, as I examine this now, I'm very happy because this x dx can be replaced with 1/2 du. So I've got 1/2 and I've got du. And so I'm going to cross off my x and my dx. And then I can also go ahead here and instead of x squared plus 2, what can I put in place there? I can put u. So I've got u to the 5th. So I've got u to the 5th. But I've got this x squared left over. Ugh. Come on. Somebody see it. Somebody see it. It's right on the board. Don't say anything. Somebody see it. Okay, I'm going to give you a hint. Is there an x squared somewhere on the board? Where is it? Okay, there's an x squared there. There's an x squared. There's also an x squared there. U minus 2. Look at this. If we just subtract the 2 over, we got u minus 2 is equal to x squared. You see it? Yeah. So therefore, now we can substitute u minus 2 in for x squared, and now we've got our complete substitution. The whole deal of the variable of x is gone. We only have u left, and now it's just a basic little bit of multiplication and then an antiderivative. So we have the 1/2 of the integral of u to the 6th minus 2u to the 5th du. No. I got to distribute this. I don't want to take this antiderivative right here. I need to write it as powers. Okay? All right. What's the antiderivative of u to the 6th? u to the 7th over 7. If we multiply by 1/2, we're going to get u to the 7th over 14. Minus, what's the antiderivative of 2u to the 5th? 2u to the 6th over 6. Yeah, because we multiply by the 1/2, the 2 is going to go away, right? So we get u to the 6th over 6 plus a constant. So the last thing I need to do is I need to substitute u back in. And so I have x squared plus 2 to the 7th over 14 plus x squared plus 6. Whoops, sorry. Ate a bowl of stupid for lunch. Over 6 plus a constant. Yeah! There it is. Now, that's pretty cool. Like, if you think about it, if you take the derivative of that, you get that. And that doesn't seem so obvious, does it? Kind of neat. No, if you wanted to, you could, but no. And so, yep. So mathematical expressions that we see in the future, calculus would like to leave it like that. Actually, we'd like to leave it like that. Okay. What do you think u is here? X cubed minus 4. So du is 3x squared dx. Okay. And when we do that, without a doubt, that's the point where you're like, Houston, we have a problem, right? Apollo 13, good movie, right? Yeah, good movie. So I'm going to rewrite it as the integral of 4x cubed times x squared times x cubed minus 4 to the 3rd dx. So I just split that 4x to the 5th up into 4x cubed and x squared. Does that help you kind of see where we're headed? Okay, so I have a 3. Do I want the 3? What do I want? So what should I multiply by? 4/3? I want to get rid of this 3. I want a 4 in its place, so I'll divide by 3 and I'll multiply by 4. So 4/3 du is equal to 4x squared dx. Yes, yep. Lots of ways to handle the constant. I will say, Abby, that when I was, I remember going through these, and anytime I saw a constant, I immediately just moved it out front every time. And I would just always deal with my constants out front. Lots of ways you can handle them. Okay, so we've got 4/3 du. I got 4x squared dx, so I'm going to cross stuff off. 4 is gone, x squared is gone, dx is gone. So 4/3 integral du. Now what? Yeah, good. The u to the 3rd, this thing right here is u to the 3rd, right? So u cubed, got that darn x cubed left. Yeah, it's going to be u plus 4. So u plus 4 is equal to x cubed. So we're going to use that little bit of information right there. And now well, what are you going to do now? Should we take the antiderivative? Now let's distribute. 4/3 integral u to the 4th plus 4u cubed du. Now antiderivative. So I'm going to write the constant this time because I'm not very smart. U to the 5th over 5. Then what? It's just u to the 4th, right? So So if I write my constant, I have an easier time handling it now. Looks like I'm going to have a 4 times x cubed minus 4 to the 5th over what? 15 plus 4 times x cubed minus 4 to the 4th over 3 plus constant. That's kind of cool. Not too bad either, huh? Okay. We got 2 left for today. We want to do that one. We want to do this one right here. And then the last lesson is actually really, really straightforward. So here's what I want you to do. I want you to look at this problem right here, and I want you to visit with a peer. I want you to try to figure out what u should be. What is u? You want to be cosecant. Why? Okay. But what's the derivative of cosecant? Cosecant cotangent. And if you look, I just got the cotangent, don't I? So that doesn't really seem to work, does it? Suppose u is cotangent. What's the derivative of cotangent? Cosecant squared of x, which looks really good, doesn't it? Except it's cosecant to the 4th and not squared. What if I wrote it like this? So, see how I just took that cosecant to the 4th, and what I did is I wrote it as cosecant times cotangent? Now that you see that, doesn't this look like a much more attractive route? Yeah. Because if we take the derivative of cosecant, we get this right here. We just come up with a negative. That's all we got to deal with. So let's do that. Let's say that u is equal to cosecant of x. So du is negative cosecant of x, cotangent of x, which I know everybody remembered that derivative. You didn't need that help. So I don't want the negative, right? So we'll just make that positive, that negative. So my substitution is very plain. It is negative integral du. And when I put in the negative integral du, what do I get to get rid of? All that stuff, right? Yeah. So what remains? Close. U cubed. What's the antiderivative of u cubed? Sweet. Yeah, because u is cosecant. Isn't there like a few moments where you're like, I feel pretty smart. Like this isn't normal math anymore. Like I must be pretty intelligent. All right, let's do the last one. What do you think u is? Good. So what is du? Just negative 1 dx. I don't have a negative 1 dx. I've got a 3 dx. So what do you want? Negative 3. Good. Negative 3 du is equal to 3 dx. So I've actually got a lot of pieces here taken care of. It may be tough to see, but if I go negative 3 integral du, negative 3 integral du, I get to get rid of the 3. I get to get rid of the dx. And this whole bottom thing there is really just u to the 1/4 power, isn't it? U to the 1/4 power. So what goes on top? I've got x squared on top, but I can't have x squared. I need a u. Okay, so I think that Abby is saying if we add the x over and subtract the u, she's saying we would get x is equal to 3 minus u. Is that correct? And then square it. Yeah. So we have x squared is equal to, if we square that, don't we get u squared minus 6u plus 9? So up here goes u squared minus 6u plus 9. Looks impossible, doesn't it? But you're so smart. Man, it must be good to be smart. -3 integral. Okay, I've got u squared over u to the 4th. If I'm dividing, what do you do to the exponents? Subtract. So this is 8/4 minus 1/4. Good. U to the 7/4. Minus, this is u to the 4/4. So we divide by 1/4, we get, yeah, 6u to the 3/4. And then the 9, that's a u to the 0/4, so it's just going to be a plus 9u to the -1/4. Have we taken an antiderivative yet? Nope. And it's kind of scary looking at those fractions, but we know how to deal with fractions. Here we go. -3 times, what's the antiderivative of u to the 7/4? Good. U to the 11/4 divided by 11/4 or multiplied by 4/11. So I'm going to go 4/11. So I'm going to be careful here because I make mistakes when I get to fractions. I don't know about you guys, but I do. And then we're going to have 6u to the 7/4 divided by 7/4 or multiplied by 4/7 plus 9u to the 3/4 divided by 3/4 or multiplied by 4/3. We're close. So this is like a -3 over 1. So we have -3 times 4 is -12. And u is 3 minus x. All over 11. Got the first term done. Is it going to be minus or plus? Plus 3 times 4 times 6. 72. All over 7. And the last one works really well because what happens to the 3's? If they're going to cancel, is it going to be plus or minus? Minus, and what's my constant out front? 36. And I've got 3 minus x raised to the 3/4 plus a constant. Look at how cool that is. Hey, you know what I love about this problem? Look at the integral. They don't look anything alike, do they? And yet, if you take the derivative of this, you're supposed to get that, aren't you? I just couldn't resist. So last year when I was looking at the problem, like, I finally have to do it. So I went back and I took the derivative of this to see if you come up with that. And you do. And it's really cool to see the algebra, how it works. So if you're interested, it's just like free fun waiting. What do you think, Luce? Maybe not. Maybe when we get home. You are now ready to complete the rest of that worksheet. So the very last page, problems like 25 through 32, some are a little bit trickier, and now you've been able to see how to work through possibly some more challenging ones. So you should be set to go. Yep, I'll go over any problem you want. I got 18 right now. Is that yours too? Kind of. And it's the integral of secant of 2 theta. Well, first of all, what is u? U is 2 theta. So what is du? I don't have a 2d theta. So 1/2 du is equal to d theta. And so you could go ahead and get rid of the d theta if you just do 1/2 integral du. And to most people, that doesn't make them happy. But if we just sit and look at it for a second, we'll have secant of u times the tangent of u. And this is where sometimes we just kind of forget the good old days of first semester. What do you take the derivative of to get secant tangent? Secant. So the antiderivative secant tangent is secant. So it ends up just being 1/2 secant of 2 theta plus constant. Hi. I don't. I'm sorry.